Okay, the last question. I appreciate that here many of you must have been seriously running out of time and just having to do another momentum type question. It was particularly algebraic as well. It must have been really quite daunting at the end. We don't have any kind of odd string happening between them though, so it certainly started off, apart from the algebra-ness of everything, it certainly started off a more standard situation. But again, I didn't see very many diagrams. What I've got here, I've got a diagram before, afterwards, and look what I've also done as well. I've labelled what this is. So this is the first collision between A and B. We know there's a collision between A and B. It then goes off and it hits the wall, and then they come back, and then there's another collision. So there's an awful lot of things going on, and lots of you just had lots and lots of maths everywhere, just splurges. You had M's, you had V's, you had U's. You weren't saying what things were. So you had a V, you had a U. I didn't know whether it was final velocity or an initial velocity, and of course, depending on whatever collision as well. So you have to be, not just for the examiner's benefit, but for your benefit as well, when you're trying to read back through your work and you're trying to maybe spot an error or just check through, you need to, I talk about signposting, you need to signpost, and you'll see, as I've done throughout, just put little headings. I haven't written down loads of words. You maybe need to, reconcile yourself to using more paper as well, just taking more space to do these things. Right, two things. As you know, the first of these is momentum. We need to use our momentum equation. So momentum of A, 2mu, momentum of B is 0. That's equal to the momentum after 2m, the velocity of A, plus 2m, the velocity of B. So you could say, well, you haven't clearly defined those variables. I mean, some of you might argue that writing down a velocity of A before equals VA might be a good thing to do, but because I've got it on the diagram, I don't need to do that. I'm clearly said this is after, and you know what it's referring to. Of course, the m's all cancel, so we've got one slightly fewer variable than we had before. So I know that 2u is equal to, or should we, there's an extra 2 there. There, of course, shouldn't be. 2u is equal to 2va plus vb. The other equation, of course, that we need to use is our restitution equation. We knew you'd be using it because it tells us up there. And that is that the final velocity of B minus the final velocity of A over the initial velocity of B, which is negative, minus the initial velocity of A, which is U, that is equal to negative a half. And I know, lots of you can, rearrange and get rid of negatives. So there weren't actually very many people who wrote it down as final velocity minus initial velocity, but I do tend to get confused with the negatives. I know my kind of limitations, so I'm just kind of extra careful when it comes to those. So we've got another equation for VB and VA. Now, of course, this U here, this initial speed, this value of U, that's what we need to find in our answer. So you have got two equations with two unknowns. U is classed as a known. That's what we've got to get to in our equation. So all you had to do was just substitute those two things. Which way? So let's say that VB is equal to a half U plus VA. Pop that into there, and we get that 2U is equal to 2VA plus the VB, which is now equal to that. And we have that should be a plus, sorry. So we have 3 over 2U is equal to 3VA. So the final velocity of A is equal to a half U. And we also know that, according to this equation here, that because velocity of B is a half U plus VA, and VA is a half U, that we know that VB is actually equal to U. So we are going to need that, I think, in part B of the equation. Now, what happens? B collides with the wall. So again, I'm being organised about things. I'm kind of doing it stage by stage. I've done the first collision. I know what the final velocities are after that collision. I now think about what happens with B. B collides with the wall. Some of you assumed it was an elastic collision. Others, weren't really sure what to do with it. We don't know the nature of that collision. We can't assume it's perfectly elastic. So there's going to be some coefficient of restitution. Shall we call it E? Because the velocity of B after that collision is U, it can be EU. Now, you didn't have to do that, because actually what it happens, it cancels in the next little bit of working. You could have just said, oh, I don't know, I'm going to call that velocity of B, I'm going to call it X, I'm going to call it F, I'm going to call it whatever. It didn't matter. Didn't matter, because that actually just cancelled. So I've now got another diagram. Look, this diagram here, I haven't put any arrows on here. I don't know why I haven't put any arrows on. Let's put them on now. So B has just come back from the wall, so it's travelling towards A, and A is still going in that direction here. So before, they're travelling towards each other. Of course, I've just got a speed here, so I'm going to consider the directions when I look at the momentum. The directions here, well, they're not both going to be going to the left. I know that because of conservation of momentum. So I assume they're both going to be going to the right. But if I get directions wrong, then, of course, I just end up with negative signs. I am going to, again, write down my two separate equations. I've got the conservation of momentum equation. So I know that 2m multiplied by a half u, this is going the other way, so it's negative EU times by m. That has got to be equal to, now I've tried to differentiate these by drawing bigger V's than there, but I'm not sure how successful that has been. So there is my momentum equation. Again, I have m's cancelling, and so I'm left with u minus EU is equal to 2VA plus VB. Now my restitution equation. So my restitution equation, so big VB minus big VA over, so I want the initial velocity of B, which is EU. It's minus EU, isn't it? Because that's in the other direction, minus a half U. And I know that this is equal to negative a half. So now I'm back to a collision between A and B. I know that coefficient of restitution is equal to a half. So I have got VB minus VA is equal to negative a half times, well, should we just make all that positive? So that will be plus a half, and then I'll have EU plus a half U. And I think what you would have probably done, you'd have probably just all multiplied that by 2, wouldn't you? So I've got 2VB, big V, minus 2VA is equal to EU plus a half U. I've got two equations, that equation and that equation. And if you look, I'm not even going to do any rearranging. If I just add those two there, so adding, sorry, it's a bit inconvenient, it's left-hand side and right-hand side, but the EU's cancel. So remember back to when I said it doesn't matter what you call that, just call it whatever you want, and it would just straight cancel. And I've got U plus a half U, so 3 over 2U by adding those. And then here, the VAs cancel. The VAs cancel, and it leaves me with a VB and a 2VB, so in total 3VB. So that means that VB is equal to a half U. Okay, and I know that's taken me a long time, and you didn't have very long at all. Of course, it's all the extra, talking that I've done. I've done a lot of talking, I'm sorry. But look how I've done my headings. Okay, look how I've done my diagrams. Please, please, please develop these skills. So when we do mechanics together next year, I'm going to want a diagram with every question, please. Sometimes, look, 1, 2 diagrams just for part A. So lots of diagrams. Really good way of organising your information, just clarifying what's going on. Okay, now part B. Find the coefficient of restitution. I need a sheet of paper. And of course, I've started with another diagram. So it's telling me about what happens, the distances. It's telling me about the distances of these collisions. So this first collision happens D away from the wall. The second collision, so this is when B's on its way back, is happening 1/5 of D. I know that A travels that distance. So from there to there, it's travelling 4/5 D. And of course, it's at a constant speed. A couple of people were using accelerations. No, it's travelling at a constant speed, so it's not appropriate to include any accelerations in your equations. B is travelling all the way from there to there at one speed, and then it gets to the wall and it's travelling back from there at a different speed. So it travels D, this bit at speed U, collides, hits the wall, and of course that speed is equal to EU. Time is equal. Of course, we are colliding there, it's getting to the same point at the same time, so the speed is equal. So what we're going to be using, an equation that involves distance, speed and time. Well, S equals ut plus a half at squared, but of course acceleration is 0. So it's basically distance equals speed times time, only we don't like to call it that because we can sometimes go wrong if we use those. So what I'm going to do is I'm going to write down an expression for the time for A. So for A, using this equation here, S 4/5 D is equal to the speed. So of course that's a little bit confusing. There I just made the speed, but the specific speed for A here is half U times by T. So T, if I divide by that, divide 4/5 by a half, I'm going to get 8/5. Now for B, 2 different sections. The first section, it travels D at a speed U. So distance equals speed times time. That first bit of time I'm calling T1. The second part, it's travelling that distance a 1/5 D at a speed EU times by that second time period. So the total time there, which is going to be equivalent to this one, is equal to D over U plus D over 5 EU. So now we just equate those. Hopefully lots of things are going to cancel. So equating these, I know that the time is equal 8D over 5U is equal to D over U plus D over 5 EU. D's everywhere. On you go. But here, we're going to need a bit of a common denominator, aren't we? Are we? Or shall I just multiply through by U? Right, 8 over 5U is equal to 5E plus 1 over 5 EU. So I know that 40, is that 5 going as well? I think that 5 might be going as well. So I'm left with 8E there times there is equal to 5E plus 1. 3E is 1 and E is 1/3. Okay, sorry, I don't know why. I got a little bit confused in there. So I guess if you had the time, I'm sure there'd have been many more successful answers. But if you are scrabbling around for time, you might think, right, no time to draw a diagram. Does help. It really, really does help. And hopefully that will be more successful. Just give them more practice of those tricky algebraic ones.